Hello, my name is Calvin Drake, and I'm part of the first Robotics Team 1511, Rolling Thunder. As with every first team, we build robots. However, our team is more than just a bunch of people who work together. We're a family. From first-related activities such as demonstrating robots to other fun activities such as volunteering at community service opportunities or just having a fun night together, our entire team works as one. We work not only for our own team, but extend our reach to others as well, be it aiding other teams by presenting beta software and hardware that we've been testing as a sneak preview for the next year, or by simply helping other teams in the pits with mechanical, electrical, or programming issues. We're connecting to other first teams constantly. Now that you know about our team, let's move on to the robot. Designed to play the 2011 First Robotics game Logo Motion, our robot Thunderous Prime boasts a long list of features and abilities, including a long reach, an entire minibot ready to be deployed at the end of a match, and an awesome arm. The basic design of the arm starts off with a relatively low-power Banebots motor, which is chained to a free-spinning jack shaft, which is then chained to a large sprocket that powers the actual arm. The intermediary shaft is to provide additional gearing reduction, making for a super speedy arm. The other main mechanism on our arm is the manipulator lock. This lock allows us to fit into the compact space required at the beginning of the match, while maintaining a rigid arm structure during gameplay. When we set up for a match, our arm folds up and our manipulator actually hooks into a pin on our drivetrain. This serves to hold it in place as well as deploy it. When the match starts, our programming moves the arm out, forcing the manipulator against the pin and pivoting it downwards. As it swings down, a pair of latches grabs onto a pin at the upper part of the arm and locks it in place until the end of the match. With such a complex gear reduction system on our arm, maintenance is a huge concern. Our strategy subteam made sure to communicate with mechanical to ensure quick and easy maintenance. Chain tensioning can be annoying as is, however with double shafts comes double difficulty. To make up for this, our mechanical team actually mounted the jack shaft on rotating mounts, which allows us to tension the chain simply by spinning the mount rather than actually taking it off the sprocket. The lower motor shaft is also similarly mounted to ensure that both chains stay tensioned throughout the competition. A good arm design is nothing without electrical or programming aspects, though. Through tri-weekly integration meetings between all the different sub-teams, we effectively communicate needs to each other. Without these meetings, our arm probably would not even be together. For any sort of automation to be written, programming need to know where the arm is. We worked with the electrical sub-team to mount an encoder on either side of the shaft. This would allow for redundancy in case of them breaking during the match. Additionally, in order to ease mechanical's worries of the arm smacking the manipulator into the ground during a match, electrical mounted little metal flags on the main sprocket, which programming uses to know when the arm is going to hit the ground on either side of the robot. The flags pass through small optical sensors without actually touching anything, which ensures that they stay calibrated and can't break. Mechanical was also concerned with the manipulator smashing into the ground when it deploys at the beginning of a match. Programming worked with them to write a small piece of code to properly deploy the arm at the beginning of the match for the drivers, ensuring a safe deployment every time. Matches are a flurry of actions in the small 2 minutes of time allowed for drivers to maneuver their robots. In order to make sure that operating the arm is simple and easy on the field, programming used the encoders from electrical to write a series of presets which automatically move the arm into position for all the standard actions drivers take, such as picking up tubes or scoring.
3, 2, 1, go. 1.7.
Moving the arm to a set position is useless, though, if it won't stay there. Mechanical worked hard to overcome any sort of accidental movement in the arm that's a result of overall robot movement, however they couldn't quite manage it. Programming stepped in and using the encoders made the arm move back to its original position if it ever drifts. When your team relies on one part of the robot to score all the points, it had better be something really special. With such mechanical innovations as multiple gear reduction for speed, a latching deployment for compactness, and moving shafts to keep chains taut quickly and easily, paired with control innovations such as optical flags and encoders to keep the arm safe, and advanced programming to make it move quickly and easily, our arm is truly a design innovation. My name is Calvin Drake, and thank you for watching.